All right, here are the notes for section 9.5, triangles and parallel lines. In the last section, we talked about a line being parallel in a triangle and creating corresponding sides. This time we're kind of working the reverse of that. And this theorem says that if a line intersects the two sides of a triangle, so it's intersecting here at B and C, and separates the corresponding segments into proportional lengths, then the line is parallel to the third side of the triangle. So if, in this particular triangle here, if AB, let me go back to my pen, if AB is proportional to DB, and that is equal to the proportion of AC over CE, right here, again, that's what we talked about yesterday, then our two lines right here, BC, is parallel to DE. Okay, so yesterday we knew that they were parallel and then we had corresponding parts of the sides of the triangle. This time we know we have the corresponding lengths of the triangle. The lines are parallel. So for our first example, we're going to determine if our lines are parallel. So we're looking to determine if SR is parallel to TU. We're going to set up our proportions here. So I'm going to go 8, oops, I don't want the highlighter anymore. The proportionate sides, let's go 4 over 8. We're going to ask if that's equal to 5 over, notice that this whole side is 15, so just to find this part right here, I have to take 15 minus 5, so that's equal to 10, because we're just talking about the parts here. Now let's check our cross multiplication, so 4 times 10, and we're questioning if that equals 5 times 8, and sure enough, 40 is equal to 40. So we can say that TU is parallel to RS. I'll go ahead and mark those as well on our triangle. Okay. Moving down to the next example. Again, we're trying to determine if they're parallel. I'll go ahead and highlight the lines that we want to look at. We're looking at MN and KL. So we're going to set up our proportions. So I'm going to go, oops, again, get the marker. 4 over 6. We're looking at seeing if that's equal to 6 over 9. Setting up our cross products again. 4 times 9 is 36. 6 times 6 is 36. So sure enough, that's equal. So we can say that line MN is parallel to KL. Moving on to the next example here. Again, we're looking to see if KL is parallel to MN. We're going to set up our proportions. Before I do that, I'm going to figure out what this length is right here. In order to figure out that length, it's going to be 11 minus 7. So this length right here is 4. Now I'm going to look to set up my proportions. So I've got 7 over 4. We're questioning to see if that equals 5 over 3. Doing our cross multiplying, I get 20 is equal to 21. That is not true. So these MN is not parallel to KL. Okay. Let's move down here. Okay. And we're looking at our triangle over here. If a segment joins the midpoints of two sides of a triangle, then it is parallel to the third side, and it is half the length of the third side. Okay. This segment is called the mid segment of a triangle. Okay. Moving down here. Oops. I'll be able to move. Make that a little bigger. All right, we are going to find here the length of CD. What we just talked about was that theorem that said the length of the mid-segment is half the length of the third side of the triangle if you've bisected the two sides, or if C and D meet at the midpoint. So it's important to note my marks here and here, saying that those two sides are congruent, and down here ZD and DY are congruent. So since we know that they're congruent, CD is equal to half of XZ. So CD, it's supposed to be a D here, is equal to half of 16. So CD is equal to 8. So again, because those sides were congruent in length, I knew that CD, so that mid-segment, met at the medians. Therefore, CD was equal to 8. In this next example, we're going to look at it the other way. Again, it's important to see that those tick marks are marking that mid-segment TS meets at the midpoints of both of the sides. So TS is that mid-segment. So we know that TS is equal to half of AC. Or in this example, we know that we have TS is equal to 4, so it's half of something. So that AC, if I'm solving this with my algebra, I'm going to multiply both sides by 2. So I've got 8 is equal to X. So AC is equal to 8. Again, we went backwards on that one. Instead of, like the first example, we multiplied by 2. The second example, we divided, or multiplied by 2 instead of dividing by 2. All right, the next example here, we've got that X, Y, and Z are midpoints of a triangle. So again, when we're given midpoints, we know that it divides these into congruent segments. So I'm going to go ahead and mark that on my triangle. Again, those are because I have the midpoints of the side of the triangle. All right, so I've got some segments that are all congruent. Therefore, I know that these triangle sides are all parallel to the side that they're across from, so to speak. So if VW, so I'm going to look at this whole part here, is given to us as 6A, then find XY. So XY is that, I'm going to get a highlighter here, is that mid-segment that is across from that side of VW. So I know that XY is half the length of VW. So I'm going to put this, so XY is equal to half the length of VW. So I know that XY is equal to half 6 times A. So half of 6 times A is equal to 3A. So I know that XY is equal to 3A. All right, next example here, I'm going to mark what we know. So let me erase some of the stuff maybe that we don't need right now. Okay, so I've got ZY, so this part here is equal to 12, and VU, so the whole length is equal to 2x plus 3. So we're solving for that value of x. So I know that 12 is half of 2x plus 3, or I know that 2 times 12 is equal to that 2x plus 3. So I'm going to set it up so you can see it both ways. So because I've got congruent parts on the sides of the triangle right here, these tick marks that indicated that they were congruent, I've got a mid-segment. So I know that that mid-segment is half the length of that longer side. So I know the other way, get my pen back, the other way I can write this is half of 2x plus 3. Move my paper up. 2x plus 3 is equal to 12. Either way you go, you're going to get the same answer, because in the blue example over here on the right, for my first step would be to multiply by 2. So then I've got that 2x plus 3 is equal to 24, which is what you get after your first step over here in the red. So 24 is equal to 2x plus 3. Either way you look at it, you can set it up. Looking to solve now, I'm going to solve the red one over here, because again, as you can see, they're both the same. My first step would be to subtract 3. So I've got 21 is equal to 2x. Divide both sides by 2. I've got x is equal to 10.5. Just double checking, it did just ask us to find x. All right, let me go ahead and erase some of the marks I've got here on my triangle, so we can write in what we got. Not quite sure why it's not erasing right now. Erase. Okay, it's not going to erase for me. All right, so UW, so this whole part here is equal to 5x plus 4, and I know that xz, so the mid-segment that is corresponds to that side, is equal to 3x minus 7. So again, I know that that mid-segment is half the length of the long side, or twice the mid-segment. So I'm going to go with twice the mid-segment is equal to that long side of the triangle. So again, I worked it that way. You could also have said 1/2 of 5x plus 4. Got my dead spot here. 5x plus 4 is equal to 3x minus 7. Either way will get you to the same spot. I'm going to go ahead and solve the one on the right. So the first step is going to be to distribute. So I've got 6x minus 14 equals 5x plus 4. Using our algebra now, I'm going to actually choose to move that 5x to the left with a 6x, so I stick with a positive x value. So I'm just going to subtract 5x. So now I've got x minus 14 is equal to 4. Final step, adding 14 to both sides, I've got x is equal to 18. I'll go ahead and solve this other one just so you can see it. Actually, I'm not even going to, because you'd want to get rid of the fraction first. So I would recommend that you multiply both sides by 2 first, which then gets you right back to where we were. So 5x plus 4, there's my dead spot. 5x plus 4 is equal to 2 times 3x minus 7. Noticing now that you have the exact same equations that we started with in that first equation here, just opposite sides. So, all right, that's your notes for section 9.5. Here's your assignment down here, assignment number 8 right now. We are worksheets on the next page.